Hi, in this video we're going to look at answering question 9, the final question on practice paper 2 for core 1. I've made this paper for AQA, but it is suitable for other exam boards as well. If you need any more information, then just contact me on Twitter at Mr_G_Walton. Okay, in this question then it shows figure 2, which is the curve y equals 2x squared plus 6x plus 7 and a straight line y equals 2x plus 13. First of all, it says find the coordinates of the points where the straight line and the curve intersect. So this is straightforward, simultaneous equations work. So first of all, we're going to put these two equations equal to each other, because both of them are y equals and y equals. So if y equals both, then they both must equal each other. So let's have 2x squared plus 6x plus 7 equals 2x plus 13. Rearrange it to make it equal 0. So 2x squared, take 2x from both sides, take 13 from both sides, equal to 0. At this point, I've got a quadratic that I'm going to have a go at factorising, but I can see that I can divide it all through by 2 first. So I can take 2 out of this and say I've got x squared plus 2x minus 3 equals 0. That's going to be a little bit easier to factorise. I'm going to have an x and an x. I'm going to have a 3 and a 1. I want positive 2, so let's have positive 3 and negative 1. That works, which means I've got two solutions for x. X can be minus 3 and x can be 1. Okay, so let's carry on working through. When x is minus 3, let's see what happens for y. So we had y equals 2x plus 13, and we can substitute it in for this. So I've got y equals 2 lots of minus 3 plus 13, and over here y is 2 lots of 1 plus 13. We didn't need that first bracket, it should be an equals. So again, working down here, y is minus 6 plus 13, so that's 7. And on this one, y is 15. So the two coordinates that I get are minus 3 and 7, which must be this point here. So this is minus 3, 7. And the other coordinate that I get is 115, which must be this point up here, 115. When you've done the work, it's always worth looking back on the picture just to see if it makes sense. This makes sense that this is minus 3, 7. This point along the y-axis and this point up here could be 7 and 15. The scale's about right. This could be minus 3. And this could be 1. Again, the scale looks relevant, so there's no reason why these values aren't right. Minus 3, 7, 115. Let's move on to the next part. Now we've been asked to work out the area of the shaded region. Now, it's a good job we did that last little bit of work, so we're going to need some of the values here. We're going to want to split this up like this. This is minus 3, and this was 1. And so we can see that we've actually got two things going on here. We've got an area under a curve, which I'm colouring in blue, like this. And we've also got a large trapezium here, which I'm colouring in red. Okay, now the trapezium has a height of 15. We worked that out previously on this side, and a height of 7 on this side. Again, these are just from our coordinates. We worked out what the y coordinates were previously, 15 along there and 7 along here. So we'd already worked this out. To work out the area of the shaded region, I'm going to take my trapezium, or the area of my trapezium, and I'm going to take away from it this blue section, the area under the curve. That's going to leave me with this dark shaded area here. Okay, let's do that then. Let's work out the area of the trapezium first. Area of the trapezium is something from GCSE that you will have known. It was the half the sum of the parallel sides times the distance between them. So let's see if we can do this. Half the sum of the parallel sides. Right, well that's 15 plus 7 divided by 2, multiplied by the distance between them, and that's this distance here, which is 4. So I've got 22 over 2, which is 11, times 4. So the area of my trapezium is 44 units square. So 44 square units. Let's write it as square units. So 44 square units. Right, now let's do the area under the curve. The area under the curve, the blue section, we can find by integrating the quadratic between -3 and 1. And we've got 2x squared plus 6x plus 7 with respect to x. So let's have some square brackets. And remember what we're doing here is increasing the power by 1, dividing by my new power. So I've now got 2/3 x cubed plus increase my power by 1 for this term, divide by my new power. So increase power by 1 was 2, divide by my new power, 6 over 2, which is 3, so 3x squared plus 7x. And this is between the limits -3 and 1. So let's start substituting some values in and see what happens then. I'll work over here. We've got 2/3 of 1 cubed plus 3 lots of 1 squared plus 7 lots of 1 minus, and then we're going to put -3 in as well. So I'm going to keep my negative values in brackets the same, plus 3 lots of -3 squared plus 7 lots of -3. Okay, so this first part, let's have a look. 1 cubed is 1, so I've got 2/3 plus 3 plus 7. Okay, and here let's see what we've got. -3 cubed is -3 times -3, which is 9, times -3 again, -27, times by 2/3, -27 is -54 over 3. Plus 3 9s are 27, minus 21. Okay, now I've just about run out of space, so all I'm going to do is just move the screen up slightly and we'll carry on working as we were. Okay, let's drop it there. Okay, let's carry on then. So the first bracket, we've got 10 and 2/3. Let's just leave it like this. So we've got 10 and 2/3 minus, and let's carry on and see what we've got from this bracket. 27 minus 21 is 6. Let's turn that into thirds. So that's 18 over 3. Minus 54 over 3 plus 18 over 3. So I've got 10 and 2/3 minus 36 over 3, which is 12. So minus 12, I think. Okay, and so we've now got 22 and 2/3. So this area is 22 and 2/3. Now, what we've got to remember is that the area of the trapezium from before, we're going to take this value away from it. So actually we've got 44 minus 22 and 2/3. Now, if I were to take 22 away from 44, I get 22. I need to take an extra 2/3 away. So I've got 21 and 1/3. So the area underneath the curve should get 21 and 1/3 square units. Okay, so a lot of working out here, but you can see just about still that there were 7 marks for this, so there's a lot going on. We've got a lot of work that we've had to do, but we've kept it neat and tidy, and we've kept going, and we've kept a track of what it was that we were trying to do. Okay, as ever, at the end of these video sessions we have a little revision card note. Be really careful on this one when with intersecting lines and areas between curves and lines. There's a lot to think about. Intersecting lines means we're going to be using simultaneous equations. To find an area bound between a curve and a line, we're going to use the top area, the area of the top line minus the area of the bottom line. Now, typically these are straight lines at the top and a curved area underneath, and you can find the area under the curve with integration. Be really careful with your limits, with fractions, with anything with negative signs in, and read the question carefully in terms of what it's asking you to do, which part you're trying to find. As ever, good luck with any exams you've got coming up, and I'll see you soon. Bye.